This video is on exercise 9b questions 4 to 6 of A-level Maths Pure 2 textbook. Question 4. Find the equation of the tangent to the curve y equals 2 to the x plus 2 to the minus x at the point 2, 17 fourth. Right, so we need to differentiate this function first, and then we can work out the gradient and then the equation. So this is the function y is equal to 2 to the x plus 2 to the minus x, right? Y by dx is equal to. So as we said, if you want to differentiate these types of functions quickly, we can just do that in 3 simple steps. So the first step is just simply writing down that function again, 2 to the x times the derivative of the power, in this case is 1, times the natural log of the number we have, in this case ln 2, and same thing for the second one. So again we write the whole thing times the derivative of the power, which is minus 1 in this case because minus x differentiates to minus 1, and then natural log of 2. Now we can simplify this. dy by dx is equal to 2x ln 2 minus, here we should be careful, minus 2 to minus x ln 2. And now we need to substitute the value of x into our derivative because we want to work out the gradient. So, and in this question, the x value, x coordinate is 2. So when x is 2, dy by dx is equal to 2 squared ln 2 minus 2 to the minus 2 ln 2. Now let's simplify this. So here we have 4 ln 2 minus ln 2 fourth. Oops, yeah, here should be ln 2. And we can also do the subtraction. So 4 ln 2 minus ln 2 fourth is simply equal to 15 fourth ln 2. Now this is our gradient. And now we can use the general form. And this is the point. So let's write down the point before we work out the equation. So the point is 2/17 fourth. And this is the general form of the equation of a straight line, which means we can use this method. And y minus 17 fourth is equal to the gradient times x minus 2, and that's it, because the question hasn't asked for any specific form for the final answer, so we can leave the answer in this form and save a bit of time. Question 5. A curve has the equation y is equal to e to the 2x minus ln x. Show that the equation of the tangent at the point with x coordinate 1, so x coordinate 1, is this. First of all, let's work out the y coordinate. Now we need to substitute x is equal to 1 into here to work out the, into here. Yeah, because this is our derivative actually. This is the equation of the tangent. Yeah, it's very easy to make a mistake when they give you more than one equation, so be careful. So when x is equal to 1, we have e to the 2 times 1 minus ln, and here should have been ln x, which here is ln 1. Now let's work out y. In this case, y is equal to e squared minus 0, because ln 1 is 0. So this is our y coordinate, and e squared is here. So this is the coordinates of the point. Now we can differentiate the function so that we can work out the gradient, then the equation of the tangent. dy by dx is equal to e to the 2x differentiates to 2e 2x, because when we have e, then the way we differentiate that is just by differentiating the power times the function again. And ln x differentiates to 1 over x. Since this is negative, then we are going to have minus 1 over x. Now let's work out the gradient. So when x is 1, then the gradient is 2e 2 times 1 minus 1 over 1, which is equal to 2e squared minus 1. This is our gradient. And it's very possible and it's very common to get some, like a strange gradients, if that makes sense, because it's not always the case that you get nice numbers for your gradient. So don't panic and don't think you might have done something wrong, because it's very common to get some strange things for your gradient. Yeah. Now we can work out the equation of the straight line y minus y0 is equal to m times x minus x0. Let's substitute the values into this. Y minus so I have y coordinate is e squared, gradient is 2e squared minus 1 x minus 1, because x coordinate is 1. And now we need to simplify this, because remember that we need to show that the equation of the straight line is this. So we have a couple of more steps. So y is equal to, let's expand this bracket. So 2e squared minus 1 times x, then minus 2e squared, and then plus 1. And also we add e squared to both sides. And now let's keep this bracket as it is. And minus 2e squared plus e squared gives us minus e squared plus 1. And this is exactly the form that we have been asked, because we should leave the answer in this form. So another point here is that you don't necessarily need to expand brackets whenever you have any bracket. In this case, let's say that here is, you can be tempted to expand this bracket and just multiply 2 squared to x minus 1 to x and so on. But, that's not going to give you the answer in the form that you're asked. So be careful. 6. A particular radioactive isotope has an activity R millicuries at time t days given by the equation R is equal to 200 times 0.9 to the t. Find the value of the R dt when t is equal to 8. So we simply need to differentiate this and work out the gradient. That's all we need to do. The R dt is equal to, so 200 is a constant and we keep that. So this is a function of this type, y is equal to a to the x, and we can differentiate that quickly in only 3 steps. As usual, we start by writing down the function again, times the natural log of the base times the derivative of the power, in this case is 1. This is our derivative, and now we need to work out the value of dr dt when t is equal to 8. So we just need to substitute t into here. So when t is 8, we have dr dt is 200 times 0.9 to the 8 times ln 0.9. And then we get the r dt is equal to minus 9.07 to 3 significant figures. Now you might be asking yourself, why did we get a negative number? And that's because here. Because remember that the natural log between 0 and 1 is always negative. And this is quite important when you solve inequalities that you have natural log of numbers which are between 1 and 0, because you need to the direction of the sign changes because you have a negative number when you multiply both sides. That's it for this video, and thanks for watching. Make sure to subscribe for the future videos. Good luck.